Well, we consider the chain rule. The chain rule. So we say the chain. The chain rule. Now, chain rule mostly we meet it in calculus, especially when you have to deal with two composite functions, because you may be given two functions like, say, define two functions like f of x is equal to x squared. That's a function, and another function is defined by g of x is equal to, say, x plus 3. So these are two different functions, but it is then possible to form composite function out of this. And so the composite function that we would be interested in is, say, f of g of x. F of g of x. But here we see that f of x is given by x squared, and g of x is given as x plus 3. Now, for us to work out this particular question, then we need to consider a situation where if we say f g of x, then what we want is that now where there is x, we put the whole of this. Where we have x here, we put the whole of this. In other words, we'll be having something that looks like it's now this, where there is x squared, you put this. So it's going to be x plus 3. But realize that if x is now x plus 3, then where there's x, we substitute this. And then it means that now we are going to have that. So we have that to be x plus 3 squared. Now, this is an example of a composite function. It's an example of a composite function. And these are the situations where we may need to apply the chain rule. Let's consider an example. We say example. Suppose you are given that differentiate. You are given to differentiate the function y is equal to 2x plus 4 cubed. Suppose you are given that as an example. So our example is, let me call this example 1. So example 1. Suppose you are asked, differentiate y is equal to 2x plus 4 cubed. Then this is the case where you need the chain rule. And let me state the chain rule now without having to derive. I'll state without having to derive. The chain rule basically says you should dy dx is equal to dy du dot du dx. So basically that is what the chain rule is. This is the chain rule. This is the chain rule. That's the chain rule. So it's what we are going to make use of here so that we are able to differentiate this particular function. So first we say, in our solution, let me just write it this end so that I continue there. So I'll be having dy dx is given by dy du dy du dot du dx. So that is the expression for the chain rule, and it's just what I'm rubbing as well. It is just what I'm rubbing as well. But now what I have is I'll be having in my solution, I'll say let u be 2x plus 3. And if I say that, that should then imply that, if I say that, then it should imply that y is equal to u cubed. Y is equal to the u cubed. So, but in my chain rule, I have dy dx is given by dy du dot du dx. So dy du, my dy du, if I know that y, okay, y is equal to u cubed, therefore dy du will be, that means we are differentiating y. We are differentiating y with respect to u. So that will mean that now here I have 3u squared. That gives me 3u squared. But then what is du dx? I know that we had said that u is 2x plus 4. Therefore, du dx, I'm differentiating now this expression with respect to x. That should give me 2 because it's just this part. And now bringing this result together, I say, therefore, or implying that dy dx is equal to dy du dot du dx. That's a chain rule. But now, what is dy du? Our dy du is 3u squared. 3u squared as such. So I need to multiply this by what is du dx. Du dx is 2. So I end up with my result as 6u squared. 6u squared as the answer. So my answer in this case is 6u squared. But then what was u? What was u? What was u? We see that u simply represented 2x plus 4. U is just 2x plus 4. So I'm going to rewrite that, bearing in mind. So actually what I'm doing is to substitute back. I'm substituting back this into this. So I'm saying dy du is equal to 6u squared. And that's also equal to 6 into 2x plus 3 squared. 2x plus 3 squared. So that becomes 6 into 2x plus 4. U is 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 4. This is 4. This is 4. This is 4. Since u is just all of this. Yeah, u is 4. U is 4. Yes, u is 4 there. U is 4. Yeah. So u is supposed to be 4. So we end up with this as the answer that is required. So it means that if you differentiate this, you get this. So that's the answer in that particular case. What one needed to remember is that chain rule simply takes care of composite aspects like the one we had seen in a situation where there are two functions. There are two functions, but it is possible to express one in terms of the other. So in this case, you remember that dy dx should be given as dy du dot du dx. Once you obtain this separately, and then you bring them together to give you a result as such. So that is that. I hope to meet you in my next video.